Let us begin, gently, with the strangest fact about falling into the sun. You would be gone long before you ever reached it. Not at the surface, not in the fire, long before either. The sun would begin to unmake you while it was still an enormous distance away, and by the time you arrived at what we think of as its surface, there would be nothing left of you to arrive. And there is a second strange fact, which softens the whole thing. The sun does not really have a surface at all. There is no solid ground to land on, no shore, no floor. It is a vast ball of glowing gas growing gradually denser toward the center, so that falling into the sun is less like landing on a world and more like sinking into a bottomless ocean of light with no bottom ever reached. Tonight we are going to take that fall, slowly and gently, from the cold dark of space all the way down toward the center, and find out what happens at each stage and why. And I promise, as always, to bring you safely back to your own warm bed at the end, which is where you will remain throughout, because this is a journey nobody will ever take. But before we go a step further, let me ask you something softly, because it matters more than you might think. If these quiet journeys through the strange corners of our universe help you set down the weight of your day and find your way toward rest, then please take just a moment right now before you settle any deeper into the warm and subscribe. It is one small tap. But it means the next of these will find its way back to you on some future restless night when sleep is a long way off and you need somewhere gentle to put your mind. And it helps, more than you could possibly know, to keep these stories being made for you and for everybody else out there in the dark tonight looking for a little peace. So if you would, subscribe and stay with me night after night as we wander together through the great slow mysteries of the universe. And tell me, if you will, from wherever you happen to be resting tonight, in whatever quiet corner of the world is holding you. Where are you listening from? And what hour has it reached where you are? Leave it in the comments below. It is a lovely thing to see all the places and all the hours gathered there together, all of us drifting off beneath the same turning sky, in 100 different countries and 100 different hours, all of us here in the dark at once. And now, let your shoulders come down, and let your breathing slow, and let the whole weight of your day loosen and fall away. Come with me out into the sunlit dark, far above the world, and let us begin the long fall toward the center of everything. Let us begin with the distance, because it is the first thing that surprises people. The sun is about 150 million kilometers away. That is an almost impossible distance to feel. Light itself, the fastest thing there is, takes over 8 minutes to cross it. If you could somehow drive there in a car at motorway speed, without ever stopping, it would take you well over 150 years. Generations of people would be born and die in the car before it arrived. So the first thing to understand about falling into the sun is that it would not be quick. From the distance of the Earth, falling freely, pulled only by the sun's gravity, the journey would take about 2 months falling, steadily gathering speed the whole way from a slow drift at the start to an extraordinary velocity by the end, but for most of that time simply falling through the dark, with the sun ahead of you growing slowly larger. And the reason it would take so long is worth understanding, because it goes against instinct. You might think that falling towards something as powerful as the sun would be fast from the very beginning. But at the start, out at the Earth's distance, the sun's pull, while always present, is gentle. It has weakened with distance. It is strong enough to hold the Earth in its orbit, but it is not strong enough to yank you inward quickly. So the fall would begin slowly, almost imperceptibly, a gradual drift that only gathers real speed as you get closer, and the pull grows stronger. It is like a ball rolling down a hill that starts nearly flat and grows steeper and steeper. At the top, near the Earth's distance, the slope is gentle and you barely move. Only much later, plunging down the steep part near the sun, would the speed become tremendous. So most of your 2 months would be spent in the slow upper part of that long fall, drifting with the sun still far ahead, and only the final stretch would be swift. And for a long stretch of that fall, it would be of all things cold. This surprises people, but it makes sense when you think about it. Out in space, away from the sun, there is no air to hold warmth, and if you are not in direct sunlight, you lose heat rapidly into the emptiness. For the first part of the journey, the sun would still be far away, a brilliant point or a small disk, not yet close enough to be truly fierce. You would be falling through the cold and the dark, watching it grow ahead of you for weeks. Rest a moment on that image, because it is a quiet and strange one. Falling toward the most ferocious object in the solar system, and for the first long while being cold. The sun ahead, growing from a point to a disk to something larger, brightening but still far, and all around you the deep cold dark of space, and the slow, silent, weightless falling. And then gradually over the weeks the sun would grow and grow. From the familiar disk we see in our sky to something larger and then larger still, swelling ahead of you until it filled a great part of the sky, and then most of it, until there was nothing ahead but blinding light, and the warmth turned to heat, and the heat began to build towards something no words can really hold. Now let us talk about what the sun actually is, because you cannot understand the fall without it, and it is not what most people picture. The sun is not a ball of fire. It is not burning in the way a log burns. Fire is a chemical reaction that needs oxygen, and there is no oxygen in the sun and no burning of that kind. The sun is something far stranger and far more powerful. It is an enormous ball of gas, mostly the two lightest elements there are, held together by its own immense gravity and squeezed so hard at the center by the weight of all the gas above that the core is under unimaginable pressure and heat. And in that core, the pressure is so extreme that the very nuclei of atoms are forced together, fused into heavier ones, and that fusion releases energy. That is what powers the sun, not fire, the forcing together of matter itself, at the heart of an object so massive that its own weight lights it. And the amount of energy this releases is difficult to hold in the mind. The sun turns something like 4 million tons of its own matter into pure energy every second. Every second, 4 million tons of the sun simply cease to be matter and become light and heat instead, pouring out in all directions. It has been doing this steadily for 4.5 billion years, and it has so much material to spend that it will go on doing it for billions of years more, and will still barely have used up a fraction of itself. That is the scale of the thing you would be falling into. Not a fire that could burn out, but a furnace so vast that it loses 4 million tons a second and hardly notices. And that furnace is not violent in the way you might expect. It is astonishingly steady. The sun is held in a perfect patient balance between its own gravity pulling inward and the heat of its core pushing outward. And the two have been matched so exactly for so long that the sun barely flickers. It is one of the most stable things in the entire universe. The ferocity is real, but it is a calm, contained, endless ferocity, held in balance, shining without pause, and it is big. This is the thing that is hardest to hold in the mind. The sun is not merely bigger than the earth. It is bigger than the earth in a way that breaks the imagination. You could fit well over 1 million earths inside the sun. If the sun were hollow, you could pour more than 1 million worlds like ours into it, and still have room to spare. It contains more than 99% of all the material in the entire solar system. Everything else, all the planets, all the moons, all the asteroids and comets, everything is less than 1%, scattered around a star that holds essentially all the mass there is. So when you fall into the sun, you are not falling onto a bigger version of a planet. You are falling into the single dominant object of the whole solar system, a thing so large and so massive that the earth beside it is a grain of dust beside a cathedral, and it has no surface. That is the second thing to hold on to. When we look at the sun and see a bright, sharp-edged disk, we are not seeing a solid surface. We are seeing the depth at which the sun's gas finally becomes thick enough to be opaque, the layer from which the light we see escapes. Above that layer, the gas is thinner and transparent. Below it, denser and glowing. But there is no line, no ground, no shore. It is gas all the way down, simply growing thicker and hotter and denser toward the center. Falling into the sun means falling into a bottomless depth of ever-thickening, ever-brightening gas. We are so used to worlds with surfaces, with ground you can stand on, that it is hard to picture a thing that has none. But the sun is not solid anywhere. It has no rock, no crust, no shore where the gas gives way to something firm. If you could somehow ride down into it, protected. You would simply pass through gas that grew thicker and thicker and hotter around you, with no moment where you landed on anything, no floor to meet. It is worlds of difference from falling onto a planet. There is nothing to hit. There is only the slow, deepening, brightening descent into something that has no bottom you could ever reach, because long before any bottom, you would have become part of the gas itself. Now let us return to the fall, because we have reached the interesting part, where the sun begins to reach out and touch you long before you arrive. The first thing that would reach you, far out, would be the light and the heat. Long before you got near the sun, the heat would become overwhelming. We think of the surface of the sun as the hot part, and it is at around 5,500 degrees. But you would not need to reach the surface to be destroyed by heat. The space around the sun, for a great distance out, is fierce with its radiation. As you fell closer, the gentle warmth of sunlight would become a blaze, and then a furnace, and then something beyond any furnace ever built. Millions of kilometers out, still far from anything you could call the sun itself, the heat pouring off it would already be far more than enough to destroy any material thing. No spacecraft could survive it. No substance we know of could survive it. Long before the surface, everything would simply come apart in the heat. We have actually sent a spacecraft to touch the sun in recent years, and it is worth mentioning because it shows just how fierce that region is. A specially built probe was sent to fly closer to the sun than anything before it, to dip into the sun's outer atmosphere and fly out again. And to survive even the edge of that environment, it had to be protected by an enormous heat shield, a thick barrier built to face the sun while everything behind it sheltered in its shadow, and it could only make brief passes, diving in and racing out again, never lingering. And that was still an enormous distance from anything you could call the surface out in the thin outer reaches. That is the closest anything humanity has built has ever come, and it needed a shield the like of which had never been made just to graze the outermost edge. For a falling person with no shield and nowhere to hide, the story would be far shorter. The radiation alone, streaming out from the sun, would be lethal from millions of kilometers away, and would grow from lethal to annihilating as you fell. You would not need to reach the sun. The sun would reach you long before across a gulf of empty space with light alone. And this is the opposite of what most people imagine. We picture falling into the sun as a sudden plunge into flame, a single fiery moment at the end of a fall. But it would be nothing like that. The ending would come gradually, out in what looks like empty space, millions of kilometers from anything you could point to and call the sun. There would be no dramatic arrival, no plunge through a fiery surface, because you would already be gone by then, undone quietly and completely by a heat that filled the emptiness long before the sun itself was near. But something even stranger happens first, and it is one of the great mysteries of the sun. The sun has an atmosphere, an outer layer of thin gas that extends millions of kilometers out into space, far beyond the bright disk we see. It is called the corona, and you can glimpse it during a total eclipse, when the moon covers the bright disk and reveals a pale, pearly halo of light streaming out into the dark sky. That halo is the corona, the sun's outer atmosphere, and it reaches out a very long way. And here is the mystery. The corona is hotter than the surface, far hotter. The visible surface of the sun is around 5,500 degrees. The corona, the thin atmosphere above it, is millions of degrees. It is as though you walked away from a fire and found the air getting hotter the further you went. Nobody fully understands why the sun's atmosphere is so much hotter than its surface. It is one of the great unsolved problems in the study of the sun, and people have argued about it for decades. So as you fell in, you would pass through this outer atmosphere, this corona, and it would be, in temperature, millions of degrees. Now it is so thin, so close to a vacuum, that the heat it would actually transfer is a subtle matter, and the fierce radiation streaming from below would be doing the real work of destruction. But there is something wonderful about the fact that the sun's reach, its atmosphere, extends so far. In a sense, the sun is far larger than it looks. The bright disk is only where it becomes opaque. Its true outer edge, the thin reaches of its atmosphere, extends past the innermost planet and out toward us. In a way, the Earth itself orbits within the very outermost wisps of the sun's atmosphere. We live inside the faint edge of the sun. Rest a moment on that. because it is a lovely and little-known thing. The sun does not end at the bright circle we see. It reaches out, thin and hot and faint, for millions upon millions of kilometers, a vast, tenuous atmosphere blowing outward into space, and our own world moves through the far outer edge of it. You are, in the most delicate possible sense, already inside the sun, and always have been. That outer atmosphere does not simply sit there either. It streams outward constantly, a steady wind of particles blowing off the sun in every direction, out past all the planets, out to the very edge of the solar system. It is called the solar wind, and it never stops. The Earth sails through it endlessly, and we are shielded from it by our planet's magnetic field, which wraps around us and deflects that stream of particles. When some of it does leak through near the poles, it makes the great glowing curtains of light in the northern and southern skies, the auroras. So even those beautiful lights are, in a sense, the touch of the sun's outer atmosphere brushing against our own. The sun reaches all the way out to us, gently all the time, and we see the proof of it glowing in the polar sky. But for a falling person, moving inward through that atmosphere toward the bright disk, the thin outer wisps would be only the faintest beginning. The real sun, the fierce, dense body of it, would still be ahead, growing, brightening, waiting. Now, what would actually happen to you in the fall? Let us be gentle but honest about it, because the stages are strange and worth understanding. You would not burn in the ordinary sense. It would be far too extreme for anything as slow as burning. As you fell into the fierce radiation near the sun, the heat would be so intense that the materials you are made of would not catch fire, but simply come apart. First, anything that could melt would melt. Then anything that could turn to vapor would turn to vapor. And then, as it grew hotter still, even the vapor would be broken down. At the temperatures near the sun, matter does not stay in any of its familiar forms. It cannot remain solid or liquid or even ordinary gas. It becomes something else, a fourth state, called plasma, in which the heat is so extreme that the atoms themselves are torn apart into their pieces, their electrons stripped away from their nuclei, everything broken down into a hot soup of charged particles. Most people learn about three states of matter, solid and liquid and gas, and stop there. But there is a fourth, and it is by far the most common of all. Nearly all the ordinary matter in the entire universe is plasma, because nearly all of it is inside stars, and stars are made of it. The solid ground and liquid water and breathable air we know are the rare exceptions, found only in cool, quiet corners, like the surface of a small planet. The universe as a whole is overwhelmingly a place of plasma, of glowing charged gas, of stars. So to become plasma falling into the sun would be to join the ordinary majority of all matter that exists, and to leave behind the rare and delicate solid state that we, briefly and improbably, get to be. That is what the sun is made of, plasma. And anything that falls into it becomes plasma too. You would not be burned to ash, because even ash could not survive. You would be broken down, particle by particle, into the same hot-charged soup that the sun itself is made of, and mixed into it, and become, in the most literal sense, part of the sun. Rest a moment there, and let it be strange rather than frightening, because there is something almost peaceful in it when you look at it clearly. You would not fall onto the sun and lie there. You would become it. The atoms that make you would be taken apart into their pieces and folded into the great glowing body of the star, indistinguishable from everything else there, and they would remain part of the sun for as long as the sun exists, which is billions of years more. It is not a landing, it is a joining. And here is a thought that follows from that, which I find quietly beautiful. The atoms you are made of came from stars in the first place. Every atom in your body heavier than the very lightest was forged inside a star long ago, and scattered into space when that star died, and eventually gathered into this world, and into you. So to fall into the sun would be, in a sense, a homecoming. The star stuff you're made of returning to a star, going back to the kind of place it came from after a very long journey out here in the cold, as a person, for a little while. Think about where the iron in your blood came from, or the calcium in your bones, or the oxygen you are breathing right now. None of it was made on Earth. The Earth is far too small and cool to forge such things. Every one of those atoms was made in the searing heart of some ancient star, under exactly the kind of crushing heat and pressure we have been describing, and then released into space when that star reached the end of its life, to drift for ages before becoming part of a cloud, and then a world, and then you. You are quite literally made of the insides of dead stars. It is not a metaphor, it is simply where the material came from. So a fall into the sun would return that material to the only kind of place that can make it. The atoms would go back into the fire that atoms like them came out of, to be held there, glowing, for the long remaining life of our own star. There are worse things to become than part of the sun. It is where you started in the end, and it is where a great deal of the universe is heading, one way or another, in the fullness of time. Now let us talk about the speed, because by the end of the fall, it would be tremendous. Remember that you would be falling for about 2 months, gathering speed the whole way, pulled ever faster by the sun's enormous gravity. And the sun's gravity is very strong, because the sun is so massive. So by the time you reach the region of the sun, you would be moving at a truly enormous speed, something like 600 kilometers every second. 600 kilometers per second. In the time it takes to say a single word, you would cross 600 kilometers. At that speed, you could cross an entire country in a heartbeat. That is the speed you would be traveling by the time you fell into the sun, and it is the natural result of 2 months of falling towards something so massive. But of course, you would never actually travel at that speed all the way to the surface, because you would have been destroyed long before out in the fierce radiation, millions of kilometers up. The great speed is what you would reach in theory. In practice, the sun would have taken you apart long before you could arrive to use it. It is worth pausing on how that speed compares to things we know, because it puts the sun's grip in perspective. The fastest spacecraft humans have ever built, at their very fastest, move at a small fraction of that. A rifle bullet is thousands of times slower. Even the Earth itself, racing around the sun at 30 kilometers a second, which is already almost unimaginably fast, would be crawling by comparison. 600 kilometers a second is the kind of speed that only the sun's enormous gravity, pulling on you across the whole long fall, could ever give you. It is a measure of just how massive the sun is, that it can fling a falling object to such a speed simply by being pulled toward for 2 months. And all of that speed, all of that tremendous falling energy, would come to nothing in the end, poured harmlessly into the vast body of the star, which would not so much as ripple at the arrival of one more small thing from the cold outside. And even if, by some impossible magic, you survived intact all the way down, you would not stop at the surface because there is no surface to stop at. You would plunge into the ever-thickening gas, and it would slow you gradually the deeper you went, as the gas grew denser, until eventually, somewhere down in the depths, you would come to rest, crushed and dissolved into the body of the star, mixed into the roiling plasma, part of the great slow currents of the sun. Let me tell you what it is like down there. In the depths you would be falling toward, because it is one of the most extraordinary environments that exists, and almost nobody thinks about it. The center of the sun is under a pressure beyond anything imaginable, the entire weight of the star pressing down from all sides. The gas there is compressed to a density many times that of solid metal, and yet it is not solid because it is so unimaginably hot, around 15 million degrees. It is a place of crushing pressure and inconceivable heat, where matter is squeezed and heated until its very nuclei fuse together. And that fusion is what makes the sun shine. And it is slow. This is the part I find most surprising and most beautiful. The energy made in that core, the light and heat born of all that fusion, does not simply rush out to the surface. It cannot. The sun is so dense that a packet of that energy trying to travel outward is absorbed and re-emitted over and over, billions upon billions of times, staggering outward through the crush of matter, and it takes tens of thousands of years, perhaps longer, to work its way from the core to the surface and finally escape as sunlight. So the sunlight that warmed your face today was made in the heart of the sun tens of thousands of years ago, and has only just now finished its slow, staggering climb to the surface, and then crossed the gulf to your window in 8 quick minutes. The hardest part of a sunbeam's whole journey. By an enormous margin, is escaping the sun. The crossing of empty space is nothing by comparison. Let that sink in for a moment, because it is one of the strangest facts about the star we live beside. The light on your windowsill this afternoon is older than the pyramids. It is older than the oldest cities. It was born in the core of the sun when the last ice age still had the world in its grip, and it has spent all the time since then working its slow way outward, absorbed and re-emitted, knocked in every direction, 10,000 years and more of struggle just to reach the surface, before its final, easy 8-minute glide to your eyes. And that tells you something about the depths a fall would take you into. The core of the sun is not merely hot and dense. It is the single most enclosed place in the entire solar system, a place so tightly packed that even light, the fastest thing there is, needs 100 centuries to escape it. Everything else in the solar system, every planet and moon and comet, is open to the sky, bathed in light that crosses to it in minutes or hours. Only the heart of the sun is so deeply buried that light itself is trapped there for ages. And that is the place, in the end, toward which a fall into the sun would carry you. Down and down through the brightening depths, toward the one truly sealed room in the whole neighborhood. Rest a moment on that, because it ties the whole thing together. If you fell into the sun, you would be falling toward a place where light itself takes tens of thousands of years to get out. The center of the sun is in that sense the most trapped place in the solar system. Even light cannot leave it quickly. And that is the place, in the end, that a fall into the sun would carry you toward, down through the ever-thickening, ever-brightening depths, into the slow, crushing, patient heart of the star. Now let me tell you why none of this can happen, because that part matters, and it is completely reassuring. You are not going to fall into the sun. Nothing on this earth is going to fall into the sun. And the reason is one of the most important and most misunderstood ideas in all of astronomy. The Earth is not falling toward the sun. It is orbiting it, and an orbit is stable. The Earth has been going around the sun at the same comfortable distance for 4.5 billion years, and it will go on doing so for billions more. It is not slowly spiraling inward. It is not gradually getting closer. It goes around and around, at the same distance, held in a balance that does not decay. People sometimes imagine that the sun is constantly pulling the Earth toward it, and that one day the Earth might give in and fall. But that is not how orbits work. The Earth is indeed being pulled by the sun constantly, but the Earth is also moving sideways very fast, about 30 kilometers every second. And the sideways motion and the pull are balanced perfectly, so that the Earth falls toward the sun and misses over and over forever. That is all an orbit is, a constant falling that constantly misses because of the sideways motion. The Earth is falling toward the sun right now, and always has been, and it never gets any closer, because it is also racing sideways fast enough to keep missing. To actually fall into the sun, you would have to cancel out that sideways motion. You would have to somehow stop the Earth's 30 kilometers per second of orbital speed, and that is very nearly impossible. It would take an almost inconceivable amount of energy. Nothing in the ordinary workings of the solar system does anything of the kind. The Earth's sideways motion is safe and steady, and it is not going anywhere, and so neither are we. There is a simple way to feel why this works, and it is worth a moment. Imagine swinging a small weight on the end of a string, around and around your hand. The string is always pulling the weight inward, toward your hand, exactly as the sun's gravity pulls the Earth inward. And yet the weight never comes in and hits your hand. It keeps circling, held out at the end of the string because it is moving sideways so fast. The inward pull and the sideways motion are balanced, and the result is a circle. Let go of the string, and the weight does not fly inward toward your hand, it flies off sideways in a straight line. That is exactly the arrangement the Earth is in, held on the invisible string of the sun's gravity, moving sideways fast enough to circle forever, never falling in. And the Earth has been on that string for 4.5 billion years without the slightest sign of coming loose or winding in. It is one of the most stable arrangements in all of nature. Orbits like ours do not decay on their own. Left alone, the Earth would go around the sun at essentially this same distance for billions upon billions of years, far longer than the sun itself will even last. In fact, falling into the sun is much harder than most people think, even on purpose. If you wanted to send a spacecraft into the sun deliberately, it would be one of the hardest possible journeys in the entire solar system, far harder than sending it out to the distant planets. Because to fall into the sun, you first have to get rid of all that sideways motion that the Earth gave you, all 30 kilometers per second of it. And that takes more energy than almost anything else you could attempt. It is, in a real sense, easier to leave the solar system entirely than to fall into the sun. The sun is the hardest place in the neighborhood to reach, precisely because everything here is moving sideways so fast, held safely in its orbit, endlessly missing. Space missions that need to reach the sun get around this in a clever way. They cannot simply cancel all that sideways speed directly, because it would take far too much fuel. Instead, they fly past other planets, using the gravity of each one to bleed off a little of their sideways motion at a time, looping past world after world over years, gradually letting themselves fall closer and closer to the sun with each pass. It takes an enormous amount of planning and many years of travel just to shed the speed that keeps a thing safely in orbit. That is how hard the sun is to reach, even when reaching it is the entire goal. Rest a moment on that, and let it be the ground under everything else tonight. We are not in any danger of falling into the sun. Quite the opposite. We are held at a safe and steady distance by the oldest and most reliable arrangement there is, an orbit that has held for 4.5 billion years and will hold for billions more. The Earth is not creeping toward the fire. It is circling it at a gentle distance in perfect balance, as it always has. And that distance is exactly right. Not so close that we burn, not so far that we freeze. We happen to orbit at just the distance where water can be liquid and life can exist, in the narrow, comfortable band around the sun where a world can be neither scorched nor frozen. And we sit there steadily, going around and around, warmed but not burned, held at precisely the distance that has allowed everything you have ever known to exist. Astronomers have a name for that band. They call it the habitable zone, the region around a star that is neither too hot nor too cold, where a world can hold liquid water on its surface. Move a planet too far in, toward the fire, and its oceans boil away. Move it too far out into the cold and they freeze solid. But in that narrow ring, at just the right distance, a world can be gentle and blue and alive. And the Earth sits, comfortably, right in the middle of it. So the very thing that would destroy you if you fell toward it is the thing that keeps you alive from where you are. The sun is fierce beyond imagining up close, a furnace that would unmake you from millions of kilometers away. And yet from the safe distance of our orbit, that same ferocity arrives as nothing more than the gentle warmth on your face on a spring afternoon, the light that grows your food, the glow that lights your whole world. It is all a matter of distance, close-up annihilation. From here, life itself. And we are held, permanently and safely, at exactly the distance where the fiercest thing in the solar system becomes the kindest. So let us come back now gently and put the whole long fall away. You are not falling into anything. You are lying still on a solid world, at a safe and steady distance from a star that warms you without ever coming close enough to harm you. The sun is 150 million kilometers away, exactly where it should be, exactly where it has been your whole life. And it is not reaching for you and never will. And the strange, beautiful truths we found in the falling are all still true, and all gentle when you hold them from here. That the sun is not fire but something stranger and steadier. That it is so vast the earth beside it is a mote of dust, and yet it holds us so gently that we are never harmed. That its atmosphere reaches out so far that we drift, in the faintest sense, within its very outer edge. That the atoms you are made of came from stars, so that you are already a little piece of star stuff, resting here in the dark. And that the light warming the world was made in the heart of the sun tens of thousands of years ago, and has been traveling toward you, patiently, all that time, to arrive at last at your window. None of these are frightening things. They are the quiet facts of living beside a star, at a safe distance, held in a steady orbit, warmed and lit and kept alive by something enormous and powerful, and from where we sit, entirely gentle. So let your breathing slow, and let the long fall and the cold dark and the swelling light and the crushing patient heart of the star all drift away into the realm of things that make interesting stories and never actually happen, and keep, if you like, just the gentlest thread from all of it. not the fall which no one will ever take, but the warmth. That right now, at this very moment, the sun is pouring out its light in every direction, and a tiny sliver of it, a few minutes old, is falling on your part of the world, or waiting just beyond the horizon to fall on it in the morning. That warmth has crossed 150 million kilometers of empty space to reach you, and before that, it spent tens of thousands of years climbing out of the heart of the star, and it asks nothing of you at all. It simply arrives, faithfully, as it has every day of your life, and warms the world, and moves on. You are on a warm world, at a safe distance, held in an orbit that has never once faltered in 4.5 billion years. Nothing is falling, nothing is spiraling inward. The sun is where it has always been, warming you from far away, and it will still be there at exactly the same gentle distance when you wake. Sleep now. You are not falling into the sun. You are held safely beside it, warmed from across an enormous gulf by a star that has kept its distance faithfully your whole life and will keep it always. There is nothing to fall toward and nothing to fear, just the steady warmth from far away and the safe dark of your room and the old reliable orbit carrying you gently through the night toward an ordinary morning. Rest now. The sun will be exactly where it should be, warm and far and faithful,